Alright, so let's do 9.1. Okay, find the value of x. If necessary, write your answer in simplest radical form. Alright, so we want to find this, and we know that this is a hypotenuse, so this is going to be our c value. So we just use Pythagorean theorem. C squared equals a squared plus b squared. We have 9 to the second. Let's make this our a, and b is our x. So this is 3 squared plus x squared, 81, 9, minus 9, minus 9, 72, x squared. Let's square root 72. This is 2 times square root of 36. Square root of 36 is 6, and then this stays. So our x is equal to 6 square root of 2. That's it. Okay. So what is this, guys? I already know this is 25 because of the 7, 24, 25 Pythagorean triple. But if you don't, that's fine. This is C. So it's x squared equals 7 squared. Remember, guys, I'm just doing the a squared, the c squared equals a squared plus b squared. And then 24 square root. That's 49. Let me take out my calculator. (24 times 24 is equal to 576, which is equal to 625. The square root of 625 is 25. Okay. Does this set of numbers form a Pythagorean triple? Let's see. So in order for it to be a Pythagorean triple, this has to apply. Just remember that your biggest number has to be the c. So this is 5 squared, which is 25. A squared, let's make this a, this b. 16 plus 4. So this is not a Pythagorean triple. So the answer is no, because the numbers do not satisfy this equation. Yep, so it's this one. A wire is needed to support a vertical pole. How much cable is needed? Okay, so they're asking for this. So this is our C. I think, yeah, this is a 3, 4, 5 Pythagorean triple. Because if we apply a scale factor of 4, then this is 12, this is 16, so this should be 20. So this should be 20. Let's see. I don't know. Let's see. If we don't remember our Pythagorean triples, that's fine. So 12 squared is 144. 16 times 16 is 256. C squared, well, yeah, C squared. This is 400, and yeah, obviously, square root of 400 is 20, so 20 feet. So you see, it kind of helps to know your Pythagorean triples because you can kind of find it out pretty easily. Like this, look, I'm not even going to do this one, guys. 7, whoops, what the heck? Yeah, look, if this is 7 and this is 24, what is this one? It has to be 25. We just talked about it. 7, 24, 25. So the answer is 25. Okay. Is this a right triangle? Yep, because it follows the 9, the 9, 40, 41 Pythagorean triple, but that one I just know it because memory, you know, but let's figure it out. So C squared, this is C. So let's do 41 squared equals 9 squared plus 40 squared. Let's see if this does equal, then we have a right triangle. So 41 times 41 is equal to 1681. 81 plus 400? No. Should be 1600, no? Yeah. 1600, which does equal this. So yes, because this equals that. Yep. Okay, let's move on. The lengths of side of a triangle are this, this, and that. Okay, so I'm just going to do this. So 0.4, 0.5, and 0.8. So remember, this has to be the C. So let's see. So 0.8 squared equals 0.4 squared plus 0.5 squared. This is 0.64. Oh, remember, when we're trying to figure out which one it is, we don't put an equal sign because we can't assume that it's equal. So we have to put a box. This is 0.16, and this should be 0.25. So this is 0.64 box, 0.41. Since the C is bigger, then we know it's an obtuse. Good. Okay, what about this? Same thing. So, oh, this one's tricky because square root of 30 is 5.477. Okay, yeah, so square root of 30 is actually the biggest one. So this is square root 5, and then 5.477. Sure. Okay, so, oh, wait a minute, why am I doing that? Why would I put it to decimal? I can just leave it as square root 30. That's actually going to be easier. So this is the C, remember. So, oh yeah, I already see it. So square root of 30 squared box square root of 5 squared plus 5 squared. So remember that this squared and this square root will cancel each other out. So this is just 30. Cancel each other out, so this is just 5. 5 squared is 25, and you already see that they're equal, so it's a right triangle. Okay? Okay, let's see this one. Okay, X. Okay, remember, so if I have a triangle with a line segment that has a connected to this point on the line segment is equidistant to the endpoints of the segment that it's bisecting, then that means that this is a perpendicular bisector. So since it's a bisector, remember, look, perpendicular bisector, that means that this has to be 24, and this also has to be 24. So let's just take a look at this triangle right here. So if we take a look at this triangle, this is 26, this is 24, and this is X. So let's figure out what that is. This is C, let's make this A, and let's make that B. 26 squared equals 24 squared plus X squared. Whoops. 26 times 26 is 676. 24 times 24 is 576 plus X squared. This will give us 100 squared. The square root of 100 is 10. Good. Okay, find the pair of numbers, well, no, for the pair of numbers find a third whole number such that the three numbers form a Pythagorean triple. Oh, okay, well, come on guys, that one's pretty easy. So we know that we don't have our hypotenuse because there's no c. So if this is 6 and this is 8, this has to be 10. It's the 3, 4, 5 Pythagorean triple. Right? 3, 4, 5, this is just by a scale factor of 2. So we have 6, 8, 10. But once again, if you don't know that, you put c squared equals a squared plus b squared, and you plug in your a, and you plug in your b, and you'll end up finding your c. Good. Okay, so once again, guys, same thing. So now I have my a and I have my c, so I'm just going to make a little triangle. This is 53. This is 28. Let's find out x, or b. So 53 squared is 2809 equals 28 squared, which is 784 plus x squared minus 74 minus 74 x squared equals 2025. The square root of 2025 is 45. Right there. Okay. Now these two are a little bit tricky. So let's take a moment to do this one. Find the integers j and k such that a, the two given lengths, the two given integers in j represent the sides of an acute triangle. Okay, so that means j, this j is going to equal an acute triangle. Okay, and this k is going to equal an obtuse triangle. Okay. Okay, so if we have 4 and 6 already as sides, and we want an acute triangle, let's do the acute one. That means that whatever side length I'm going to get here as my third possible side length, in this case being j, it has to be smaller. It has to be a number that when I implement it, it will give me an acute triangle. So the first step, which means that the c, the hypotenuse, has to be shorter than the sum of these two lengths. So that means that the first thing I have to do is find what are the possible side lengths at all. And how do we do that? Well, the third possible side lengths of a triangle are greater than the sum, and less than the difference. So let's figure that out. So what is 6 minus 4 is 2. And then less than the sum, what's 6 plus 4? 10. So it has to be somewhere between 3 through 9, right? Because it's not included, it's not non-inclusive. Okay, so, okay, really I have a bunch of options. Let's choose 3. So if this answer was 3, because we're just picking the first one, if this answer was 3, let's try it. What is 3 squared? 3 squared is 9, 4 squared is 16, and 6 squared is 36. Look at this. Look what happens here. 25. Oh. We want, okay, since it's acute, we already know we want this. C squared is less than a squared plus b squared. We want this. So let's see. Will 3 work if we do this? Well, this would have to be 6, so this is 36. A squared, let's say a is the 3. This is 9 plus 16. That's obviously not going to work, right? Because this is 25. Is 36 less than 25? No. So that means instead of 3, let's pick 6. Okay? So that means we would have 6 squared, which is 36, 4 squared, which is 16, and then 6 squared again, which is 36. Actually, that's not going to work because... Okay, let's try 7. 7. Okay, so that means that my C would be 49, right? Because 7 is the greatest value. So in this case, this will be 49. 4 squared is 16, and 6 squared is 36. 49 is less than, what is that, 52, right? 36 plus 16. Yep, 52. So this is actually true. So that means this integer could be 7, and we'll get an acute triangle. There's other answers for this. There's multiple answers that we could have picked, but we just picked 7. Okay? So now let's do this one for k. So that means k has to satisfy, it has to be obtuse. So that means the c has to be greater than a squared plus b squared. So I'm just going to choose the highest number that I can. I'm going to pick 9. Even though it says a here, I'm going to pick 9. Okay? So if 9, then that means this is 9 squared. That means that this c is 9 squared. So I'm going to pick 81. A squared would be 16 plus c squared, which is 36. 81 is clearly bigger than 52. So that means 9 also worked. So this answer could have been 8 or 9. It didn't matter which one. The multiple choice, it would have given you answers for any 8, 9, and some other numbers too. So we're definitely going to do this one in class because this one's tricky, but that's how you go about this problem. So let's do this next one. Okay, same thing. So this needs to be acute. So that means it has to satisfy this. C squared is less than a squared plus b squared. And this has to be obtuse, so this has to satisfy that. Okay, cool. So we first got to find the possible missing side lengths. So greater than the difference. So x has to be greater than 8 minus 3 is 5. And less than the sum, which is 11. So let's pick 9. Let's pick 9 for this integer right here. Yeah, this should probably work. So let's pick 9 for j. So let's say 9 is j. So that means this would be 81. 9, because 3 squared, and 8 squared is 64. See, that's not going to work. It's not going to work. Because this would be 73. So that's not going to work. So let's pick, I know it says 8, but let's pick 7. Let's pick 7, okay? So if it's 7, now 8 is the c. So this is 64. 3 squared is 9, and then 7. So this is 49. Is this going to work? Nope. That's not going to work. So let's pick 8. Let's see why they chose 8. So that means 8 is also the hypotenuse, which is fine. So 8 squared is 64. Is that less than... Oh yeah, it's obviously going to make sense. 64 plus 9. So yeah, so this obviously satisfies this, which is 73. So that means this 8, if j was 8, then the side lengths of 3, 8, and 8 would make it acute. So let's see this one. See, they put 9, but let's say we want to put 10. You know, let's just try to be different. So 10. Because remember, it could be anything between 5 and 11 non-inclusive. So let's pick 10. So if I pick 10, then this will be 100. A squared is 9. And then 3 squared is 9. And then 8 squared is 64. So yeah, obviously 100 is greater than... What is this, 73? So 10 could have worked as well. 9 worked fine, but so did 10. Okay? So that's it. We'll definitely go over these problems in class so you guys can ask